Friends, the harsh reality is if you don't innovate, you eventually go by the wayside. The ever-increasing pace of new technology is a blessing and a curse. It provides us with the means to do things more effectively and efficiently, and in some cases do things that we never even thought possible. It provides us with the ability to do a lot more with a lot less, but at the same time, it forces us to abandon things and methods that in some cases we've invested in heavily. It forces us to adopt new methods, techniques, and even new ways of thinking about things. There are huge opportunities along with huge risks. More specifically, in recent years, product designers and manufacturers have adopted and settled upon a common modus operandi. Product definition data is created using powerful CAD systems and then transmitted from engineering to manufacturing using step files and 2D drawings. Since many manufactured products are eventually created by automatic machinery, the step file became indispensable. As we moved from drafting our most complex products using paper, T-squares, triangles, and drafting boards to 3D solid modeling on supercomputers, we were forced to change. The change provided us with the abilities that were amazing. The 2D drawing, usually expressed with a PDF, was available for the material properties, the tolerances, inspection data, surface finish, notes, and manufacturing processes, and all the rest. It was a system that worked extremely well and has enabled every industry from aerospace to automotive, medical consumer products, and a bunch of others. However, we do well to remember that when 3D CAD and solid modeling were first invented, it took a while before many people, especially those who were really good on the drafting board, fully embraced the technology. But eventually, all the holdouts were won over. And now it's time to change once again. It's time to embrace model-based design and take advantage of the exciting and incredible time savings that model-based design affords us. It's time to have more accurate models that actually contain more of the product definition data in a way that is streamlined and unambiguous. It's time to abandon the 2D drawings and all the time it takes to make them. The worrying about placing a perfect views, making the right extension lines, the fonts, the placement of notes, and a lot of the non-value added effort. It's time to fully embrace model-based design. Model-based design is made possible by the fact that our computers are 100 or 1,000 times more powerful than they were just a decade ago. It's enabled by the huge success and the overwhelmingly large and sophisticated community of engineers that use the most powerful CAD tools ever devised by humankind. It's enabled by the combined experience of thousands of engineers that are trying their best to be as competitive as they possibly can. And as I see it, and especially from my perspective and experience, one of the main components to model-based design is PMI, Product Manufacturing Information, the ability to annotate solid models right on the model. The key dimensions, notes, datum callouts, and all the other GD&T symbols go right on the model where you can see it right in the CAD system as you're designing. The benefits that this provides are many. It saves time because you don't have to create a bunch of 2D views. It's more descriptive because the person using the model can rotate and zoom in and zoom out and find out exactly where those dimensions point to. And most importantly maybe, it provides the opportunity to do automatic tolerance stack-up analysis. So, the process of creating PMI is easy. Let me demonstrate. I have here a very simple aluminum part that is machined. It's got some holes in it. And I'm going to, as quickly as I can, create the different dimensions that would be required to have somebody understand what this part is all about. And so, as you can see, I'm putting on the basic dimensions here. I'm putting them on using PMI. I'm putting them on choosing the planes that I want the dimensions to show in. And I'm going as fast as I can as I narrate what I'm doing here. So
as you can see, I'm not having to create all of these different views. I'm putting them right on the view of the solid model. Here's a call out for the holes. For these holes, I think I would like to have some targets. So I'm using the center mark. So I'm going to select the circle center here and the circle center here. And I'm going to put the datum target symbols right there. There they go. And I'm going to dimension from this edge to the target symbol. So there's a 0.5 dimension there, and then from this edge to the target symbol again. Zoom up a little bit over there. And from this edge to this target symbol. So you can see how easy it is to place those holes, and the hole dimensions are created like that, big hole callouts. Let's put this one over here. I need the height of this boss here, so I'm going to go from this circle center to, let's say, that circle center, and put the dimension on this plane here. Okay, what am I missing? I don't know. Let's start putting on the GD&T. I want a datum feature symbol. I want plane A to be here, so I'm literally just selecting that face, and I'm selecting a plane to put plane A on. Plane A. Now next is plane B. This is going to be plane B right here, datum plane B. So I'm just going to hover and hold and drag away. I want plane B to appear on that little plane right there. There we go. I'm going to put datum C just for giggles right in the middle of here, so I'm going to just select that, and select that little entity, put it over here. So as you can see, this gets to be very, very quick. I want this plane right here parallel to plane A. So I'm going to go with my feature control frame, and I'm going to select that plane, and I'm just going to move it up and put it there. And once I do that, I can select my characteristic. Here's my parallelism to 0.01. Here's my primary datum plane A. So okay, so that's very simple to do. As you can see, let's see, I want one more thing on here. I want a note. I'll do a note, and the note will be a material call out. I'll just write material. Let's have all caps. Material AL 6061, and I'm just going to select, let me see where, I'm going to select this plane right here, and right here will be the plane where I'll place the note, just like that. Let's place it up here. Doink. Like that. Okay, so now I have a dimensioned part. You can see how quick and easy that was compared to the eventuality of me creating the classical 2D drawing, where I'm doing all these, all these views, and really, watching carefully where I put all the dimensions and so on and so forth. Well, these dimensions are all in 3D, and so you can very easily, when you rotate the model, you can very easily see exactly where they're pointing to and exactly what they are. And all of these dimensions would show up if you output a JT file. So here you can also see that as I rotate in the different views, the notes, like for example, let's see, here's my material 6061, right? If I look at it from this direction, it switches around very nicely for me to see. So this is a very, very nice way to create your PDD, your product definition data. And of course, the next phase would be to hand it off to manufacturing. So you can easily say File, Export, and you can go to the JT format, JT, and you basically you create an output file and data to export, parts, assembly structure. I don't need that. And so I'm going to do file, and normally I would just go and select a suitable location, and this is going to be called PMI demo, and I'm just going to place it on my right in a directory here. Let's do projects 2023 PMI. Model-based design. Here we go. And say OK, and say OK. And it's that simple to fully dimension a component. I think that's a fantastic way to go, and it is definitely a paradigm shift to think of handing somebody product definition data as a 3D part with all these annotations on it, rather than a PDF, a 2D drawing flat. It's the wave of the future, and there's a huge amount of advantages to doing it this way. But you can see how easy it is, and thanks for watching.